Welcome, everyone. Think of today's explainer as a special guest lecture for Theoretical Evolution 101. We're going to do something, well, a little dangerous. We're going to completely rewrite the history of life on Earth, not by looking at what actually happened, but by exploring what almost didn't. You know the textbook story, right? 66 million years ago, a mountain-sized rock slams into the Yucatan Peninsula, the dinosaurs are wiped out, and eventually us humans inherit the Earth. But what if that cosmic coin flip landed differently? What if that rock arrived literally just 4 minutes earlier and hit the deep Pacific Ocean instead? Today, we are charting a continuous, uninterrupted history of 66 million years of dinosaur dominance.
Okay, let's dive into this. Think of this as our syllabus for today's class. First, we'll look at the asteroid that missed. Then we'll examine the dinosaur biological advantage. After that, we'll watch them adapt to extreme climates, conquer the grassland revolution, and explore the evolution of dinosaur intelligence. And finally, we'll take a look at Earth without human civilization.
Section 1. The asteroid that missed. Let's jump right to that absolute knife edge of extinction 66 million years ago. It's really the geography of a single moment that changed the universe.
Our timeline today maps out a history that never actually happened, but biologically speaking, it easily could have. We're tracking a totally alternate path, from that Pacific impact miss 66 million years ago, right through the extreme heat of the Paleocene-Eocene thermal maximum, moving into the Miocene grasslands and going straight into the freezing Pleistocene ice ages.
For decades, we thought the sheer explosive impact of the Chicxulub asteroid is what doomed the dinosaurs. But a 2025 study led by Katarina Radychkina totally changed that narrative. They found the impact released only about 67 billion tons of sulfur from the Yucatan's sulfur-rich rock. That is actually 5 times less than we previously estimated. So the whole extinction event balanced on a literal knife edge of geography. If that asteroid had arrived just 4 minutes earlier, the Earth's rotation would have placed the deep, open Pacific right beneath it. No shallow sulfur-rich shelf means drastically less sulfate aerosol injected into the sky, which leads to a vastly milder winter. Sure, photosynthesis stumbles for a bit, but it absolutely doesn't collapse. The skies clear within a few years, the forests regrow, and the dinosaurs who, remember, had already survived 165 million years of volcanic winters and climate shifts, they just brush off the dust and continue their reign.
Section 2. The dinosaur biological advantage. So, with the apocalypse officially canceled, why did the dinosaurs maintain their absolute, unbreakable grip on the planet? Why didn't the mammals ever take over? Well, it all comes down to foundational biology.
Dinosaurs actually possess biological systems that permanently locked our early mammalian ancestors out of the large animal niches. Just look at their breathing. Mammals, like us, use tidal breathing. It's a two-way system where air goes in and oxygen-depleted air comes back out the exact same pipe. Honestly, it's incredibly inefficient at massive sizes. Dinosaurs, on the other hand, likely utilized a unidirectional airflow system, just like modern birds do today. Air flows continuously in one direction over the lungs, extracting oxygen with every single breath, inhaling and exhaling. It's a game changer. And then there's reproduction. Mammals are completely bound by live birth. Think about it. An elephant invests 22 metabolically exhausting months into a single calf. If that calf dies, all that energy is just gone. But dinosaurs? They were egg layers. A 30-ton sauropod could drop dozens of eggs with relatively low metabolic cost. That provides just massive reproductive resilience against predators or natural disasters.
Furthermore, we just have to marvel at their incredible skeletal efficiency. Dinosaurs had pneumatic bones. Basically, these were bones filled with air sacs directly connected to their respiratory system. Mammals, we have dense, solid bones. Think about the biological engineering here. A 30-ton dinosaur skeleton is proportionally so much lighter than a 30-ton mammal skeleton would be. This fundamental biological advantage allowed dinosaurs to grow into towering giants, leaving mammals forever crowded in the underbrush as small, nocturnal creatures.
Section 3. Adapting to extreme climates. Because, biological superiority isn't just about being huge, it's about adaptability. Let's fast forward our lecture 55 million years to a period of devastating global heat.
During the PETM hothouse, global temperatures spiked by 5 to 8 degrees Celsius. Now, mammals generate massive internal heat, meaning they easily overheat at large sizes. But dinosaurs were equipped perfectly for this. The massive dinosaurs utilized gigantothermy. Their enormous bulk meant they absorbed and lost heat extremely slowly, which kept their internal temperatures incredibly stable. And the smaller, feathered dinosaurs? They used their plumage not just for warmth, but as literal heat shields. They could erect their feathers to reflect solar radiation right away from the skin, or spread their plumage to catch the breeze, initiating some highly efficient evaporative cooling.
And this brilliantly illustrates how that adaptability swings both ways. Millions of years later, during the freezing Pleistocene ice ages, we'd see the rise of creatures like the woolly Triceratops. In colder climates, Bergmann's rule dictates that animal populations grow larger to conserve heat. So our Arctic-dwelling Ceratopsian ancestors would have evolved much stockier, barrel-shaped bodies. Also notice how the massive frills from the Cretaceous are heavily reduced. Why? Because elaborate bone structures are just a massive waste of heat in the cold. Instead, they'd be covered in dense, shaggy proto-feathers, their breath steaming in the tundra air as they plow through the deep snow.
Section 4. The Grassland Revolution. Extreme heat and cold are one thing, but roughly 23 million years ago in the Miocene epoch, the dinosaurs faced an entirely different kind of environmental enemy: grass.
Now, grass is highly abrasive. It's packed with these microscopic silica shards that completely destroy teeth, and it creates wide, flat plains with absolutely nowhere to hide. This forced a massive evolutionary shift from forest-dwelling ambush tactics to open plains survival. Plant-eating hadrosaurs evolved even faster tooth replacement batteries just to grind through this relentless sandpaper. Ceratopsians developed wider beaks and grouped into massive armored herds for collective defense. To survive out in the open, you either had to be heavily armored or incredibly fast. Ornithomimosaurs, the ostrich dinosaurs, adapted by concentrating all their weight on a single toe, allowing them to sprint across the plains at 60 kilometers per hour. And what about the mighty T-Rex? Well, in an open plain, a heavy ambush predator simply starves. So tyrannosaurs shed their immense bulk. They became leaner, faster, and highly coordinated pack hunters, hunting very much like modern wolves do today.
Section 5. Evolution of dinosaur intelligence. This brings us to one of the most absolutely fascinating topics in theoretical evolution: cognitive development. What actually happens when you give feathered dinosaurs tens of millions of years of uninterrupted brain development?
First, we have to look at the current scientific debate around theropod intelligence. Back in 2023, neuroscientist Susanna Herculano-Hausel claimed that if you scale T-Rex brains like modern birds, they might have had 3 billion telencephalic neurons. That is baboon-level intelligence. But the paleontological community definitely pushed back on that. In 2024, Kai Kasper and colleagues argued that scaling them like reptiles is much more accurate, putting the T-Rex at around 360 million neurons. So smart for a reptile for sure, but definitely not a primate. However, this entire debate shifts when we look at a different, much smarter group of dinosaurs, the Troodontids.
Now, what's really interesting about this concept is the stark contrast between human ego and evolutionary reality. Back in 1982, Dale Russell imagined a highly evolved, intelligent troodontid, the Dinosauroid. It looks incredibly humanoid, right? But honestly, this is just anthropocentrism. Evolution absolutely doesn't inevitably point toward a human body plan. The far more likely reality is that a fully evolved, intelligent troodontid would look like a large, bipedal, feathered animal. It already had grasping hands, binocular vision, and an avian brain architecture that's very similar to modern crows.
So how exactly would they use that intelligence? Let's thoughtfully contrast these cognitive relationships with the world. With 66 million extra years of evolution, troodontids wouldn't be building skyscrapers. They would exist beautifully and seamlessly, right within their environment. They would modify sticks to probe burrows, use rocks as anvils to crack open nuts, and pass these learned social traditions down through generations using really complex, modulated vocalizations. Unlike human industrialization, which pumps carbon into the atmosphere, creates synthetic chemicals, and triggers rapid mass extinctions, dinosaur intelligence would be flawlessly integrated into the ecosystem. They'd be brilliant, but entirely unself-consciously so.
Section 6. Earth without human civilization. Let's move into our final thought experiment for this class. Let's look at Earth right now, in the present day, completely untouched by human hands.
If you were to view this alternative Earth from orbit tonight, the dark side of the planet would be entirely black. No city lights, no urbanization whatsoever. It is a pristine, Pleistocene-style ecosystem in full vibrant bloom. The massive megafauna that we wiped out in our timeline, they are alive and well here. Every ecological niche is occupied, and the food webs are incredibly resilient. It's hauntingly beautiful, but it's fundamentally a world without witnesses. There's no one there to write poetry about the stars, no one to name the mountains, and absolutely no one to document any of it.
So, the crucial point is this. We really like to think of ourselves as the inevitable destination of 4.5 billion years of planetary history. But actually, scratch that, we aren't. Evolution doesn't strive to create human-like questioning consciousness. It only cares about one thing: survival. And by that metric, the dinosaurs, with their 230 million year continuous reign, are the absolute pinnacle of biological success. The mammals were simply small creatures hiding in the margins who basically just got lucky when the sky fell.
We exist entirely because of a 4-minute cosmic coin flip. Our art, our cities, our ability to even sit here and analyze this explainer together, it was all bought and paid for by the absolute worst day in the history of complex life. If that asteroid had missed, the dinosaurs would still be here and we wouldn't. So I leave you with this to ponder. Would a thriving, brilliant, ecologically perfect world without us be a lesser world or just a beautifully indifferent one? Thank you so much for joining me for Theoretical Evolution 101. Until next time, keep questioning the timeline.